This lesson is on function notation. When you are done with this lesson, you should be able to evaluate functions and determine the context of a problem written in function form. Function notation. Functions are fundamental tools that convert inputs, values of the independent variable, to outputs, values of the dependent variable. So it's important, inputs are independent, outputs are dependent. So exercise 1 should be review. So why don't you pause the video and do parts A, B, and C, which is just substituting those values in. If you don't know how to do this, this would be a great question to ask in class tomorrow. The first one is 13. The next one is -12. The next one is 13. And G sub 0, or G of 0, is 4. H of 3 is 8. And H of -2 is 1/4. Hopefully you did not find those too difficult. Remember that X is the value inside the parentheses. It's that simple. So, although this notation could be confused with multiplication, the context will make it clear that it is not. The idea of function notation is summarized below. So function notation, y equals f of x. So remember, y is your output, x is your input, and f is a notation of the function. Okay? So it does not mean f times x, it's a function of x. Recall that function rules commonly come in one of 3 forms: equations, graphs, and tables. The next few exercises will illustrate function notation with these 3 forms. Boiling water at 212 degrees Fahrenheit is left in a room that is at 65 degrees Fahrenheit and begins to cool. Temperature readings are taken each hour and are given in the table below. In this scenario, the temperature T is a function of the number of hours H. So this is our X, this is our Y. This is our input, this is our output. So evaluate T of 2. Well, remember, 2 is your X value, or in this case, your hours. So at 2 hours, we have 104 degrees Fahrenheit. At 6 hours, we have 68 degrees Fahrenheit. So part B is tricky. For what value of H is T of H equals 76? So we're looking for the input, they gave us the output. So we have to look in this row for our Y value, or in this case, our degrees Fahrenheit. 76 takes 4 hours, so H equals 4, because T of 4 equals 76. So in the first scenario, they gave you the input, you had to find the output. In part B, they gave you the output, you had to find the input. So, part C, between what 2 consecutive hours will T of H equal 100? So look for the output to be 100. Well, it would be between hours 2 and 3. So between 2 and 3 hours. And our last example, exercise 3. The function y equals f of x is defined by the graph shown below. Notice it's a function because it passes the vertical line test. Each x has only one y. Answer the following questions based on this graph. You try. So just like we did with a table, it's the same idea. Maybe it would help you to make a table. So if the x value is -1, +1, and 5, what are the y values? So if x is -1, the y value is 0. If x is +1, the y value is 4. If x is 5, the y value is -4. Pretty cool. So, evaluate f of 0. What special feature on the graph does f of 0 correspond to? So 0, I'm just going to add on, is 3. But what is 0 called? So what special feature is f of 0? Well, when x is 0, that is the y-intercept. Part C, what value of x? Solve the equation f of x equals 0. So now we want the output to be 0. So we want the y value to be 0. So what are the x values that give us that? Well, we already said -1. Now we're going to look, oh, here's another one, 3. And here's another one, 7. So x equals -1 or +3 or +7. And what does that correspond to? Well, if the y value is 0, that's the x-intercept. And lastly, between what two consecutive integers does the largest solution to f of x equals 3 lie? Well, if you drew your horizontal line at 3, we have 3 solutions. We have x equals 0, 2, and then between 7 and 8. And they wanted the largest solution, so these are not it. So between 7 and 8. Good luck with this lesson. If you have any questions, make sure you ask.